Regents exam, Algebra 1, August 2016, problem number 19. What are the solutions to the equation 3x squared plus 10x equals 8? In this problem, we are asked to determine the solutions of the quadratic equation. We can find the solutions in a couple of ways. We can go ahead and graph the function and find the solutions by using a graphing calculator. Or we can attempt to factor out the quadratic function and use the zero product property to find the solutions. Let's first solve the problem by graphing the function. We can find the solutions by graphing in a couple of ways. We can graph two distinct functions. The functions can be obtained by using the expression on the left and right side of the equation. In this case, we can graph the function y equals 3x squared plus 10x and graph the function y equals 8 on the same graph. Doing that, we obtain the following. Now we need to determine where the first function intersects the second function. We can determine this by inspection. Looking at the graphs, we see that both functions intersect at the point 2/3, 8, and -4, 8. We can also find the solutions by rewriting the equation and setting it equal to 0. So we subtract 8 from both sides of the equation and simplify. We then graph the function 3x squared plus 10x minus 8. The solutions to the equation will be the points where the function crosses the x-axis. Graphing the function, we see that this function crosses the x-axis at the same points as the previous graph. Either of the two methods will work if you're trying to find the solutions of an equation. You can graph the expressions on the left and right side of the equation and find the points where both curves intersect. Or you can set the equation equal to 0 and find the points where the curve crosses the x-axis. An alternative way of finding the solutions of a quadratic equation is by factoring. We start by rewriting the equation by setting it equal to 0. So we subtract 8 from both sides and simplify. Notice that we have a quadratic trinomial with a leading coefficient that is greater than 1. So we will use the method of decomposition and grouping to factor out the quadratic trinomial. We first need to multiply the constant term, in this case, -8, by the leading coefficient, in this case, +3, obtaining -24. We then need to find two integers that multiply to -24 and whose sum is the coefficient of the linear term, in this case 10. We can systematically go through all the possible combinations until we find a perfect match. The integers that multiply to 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. We can obtain -24 by making one of the integers negative. Since we want the sum to add up to +10, we should use the integers 2 and 12 and make 2 a negative integer so that we obtain +10 when we add the integers together. Now that we have found our integers, we proceed with the decomposition step and decompose the linear term, in this case 10x, as a sum of these two integers, in this case -2x and +12x. Now we proceed with the grouping step. So we're going to group a decomposed term with a non-decomposed term. In this case, we will group together 3x squared and -2x, and group together 12x and -8. Next, we factor out the GCF from each grouping. For the first grouping, it is x, and for the second grouping, it is 4. Doing that, we obtain the following. Notice that we now have a common factor between both terms. In this case, the quantity 3x minus 2, this is a good sign. The presence of a common factor indicates that we are on the right track. The next step is to factor out this quantity from both terms as follows. We now have the complete factored form of the quadratic trinomial. The final step is to use the zero product property, set each factor equal to 0, and solve for x. Doing that, we obtain x is equal to 2/3 and -4. Looking at the options, we see that the first option is a perfect match, so option 1 is our answer.